not my strongest week. I feel like other weeks I know it very well and I'm very prepared, but
Yeah. It's just I use a lot of words that I don't know the meaning of so much.
yes.
Like,
Yeah.
I don't remember reading X bar so much.
Yeah. It's like, where did that come from?
Right?
Yeah, that was weird.
Okay.
So.
But and the thing about the preparation is they didn't do anything that was not normal. So all the examples are normal distribution. So I don't know if
Yeah. So
like
what's
later
not
this
normal?
we're gonna do abnormal or not normal.
Yeah.
Or I don't know.
Come here.
But I wonder if X bar is like the X and that is the mean.
Hmm.
You know
Yeah, I'm not for sure.
well,
Like, I don't know where that came from or what that even is. I just kept
right.
thinking about it. Like, okay. Does not make sense.
Did you do the or did you
Like, you gotta go drive over there so I can hear. Did I do what?
the hang on, I'm trying to figure out what it's called. The grid. Like did you find the on the preparation 2, part 2 with all the numbers?
Oh, I didn't write it down, but I was just trying to
That's
figure it
fine.
out in my head.
I
And
just because forward part 2 is just said find the mean and then compare it to other
yeah.
people's
Mhm.
stuff. It's like we do find the mean regularly, right? We just add it up and then divide it by the sample
Yeah. By
number.
how many? Yeah. By
Because
add up five
remember
of
one
them
to
and
add them
divided by
up.
the 5. Right.
Yeah. Okay, so that's good. Okay, so what is wrong with my is okay. What? Okay, I keep scrolling. No.
For what?
I'm scrolling on the screen and it
Yeah.
keeps going back up to the
Oh.
chart, like it's letting me scroll
Weird.
down.
Huh.
I don't know.
That is way weird.
Okay. Okay, it's fixed now.
Oh, good. Okay.
Alrighty. Looking at the part B,
Mhm.
the sampling distribution, because I got the mean of 43,240, so it's
Okay.
kind of on that's on the lower side of the bell.
Uh-huh.
And I only did it once. Do you remember where yours was? Or like was it close?
I think I did 44 through 52. Let me do it again real quick. I can't remember. Oh, okay. So mean 48,000.
Okay, so that's like between ours, it's like right in the middle.
Yeah.
But so the point of this is the sampling distribution of the sample mean is that's taking all of the numbers, the sets of 5 randomly, and that's doing all of the sample means, right? And that's what creates the bell curve, right?
Okay. Yeah.
I think that's what I interpreted it as, because it kept saying you only have your one sample mean. So
Yeah.
we only took 5 random numbers one time. We didn't do it, so many times that it got us that. And I think that's because that's what
What it's
the
trying to explain. If you just take yours, then it's probably going to be different than what somebody else gets.
yeah. So.
Slide. I'm going to go change diaper.
All right. What else does it say? Does your sample mean appear to be unusual?
No.
No.
You sure? Are you okay?
Let's go. Come sit by me. Sit by me. Come sit by me.
I'm sitting by you.
Come sit by right here. Sit by me right here, Mom.
Okay, well, just a minute. Okay.
All right. And I think for part C, I think it would just be or usual or not
Yeah.
unusual.
Sit right by right
Yeah,
here.
the one sample mean, and it falls in the bell curve somewhere
Yeah.
because you only have 5 random ones.
Mhm.
So my highest one was 47, and you have numbers on here that's like 59,500. Looks like one of the highest ones.
Yeah.
Kiki.
I guess was usual, but
Kiki.
that's not skewed to one side at least, probably.
Yeah. And then part D is where it was saying, when compare your means.
You have different means than everyone, but
And I'm guessing they'd all just be somewhere in that bell curve.
yeah.
Oh, there's my clock.
Where's your
Okay.
My clock.
Yeah. Okay.
It was what it's talking about. It's kind of easy. 'Cause
Yeah.
it's just saying everything that's already in the question.
Nice.
Because it's normally distributed. I mean, it has the mean of 529, the standard deviation. And if you just use those equations it gave us in the reading,
Uh-huh.
To find the standard deviation of the sample,
Uh-huh.
it's taking the original standard deviation divided by the mean, or or not the mean, the n. Is that n is population? So let's see. Yeah, n equals 10.
Oh, my clock. But I made
Standard deviation of 13.
my clock.
Okay.
My clock.
That wasn't too difficult to do.
Yeah, that wasn't too bad. Just took me a little bit to understand what I was asking.
Right?
Okay.
It's just a matter of like, okay, where did they get this information from?
Yes.
And then, because like with problem, I think it's problem 1. Let's see. Or part 1, the whole thing. It pretty much is just talking about. It's the same thing, actually.
Yeah. Uh-huh.
And then the central limit theorem and the law of large numbers. Does that make sense?
Yeah. Mm-hmm.
Okay.
So, yeah, I'm still not 100% on what the X bar is. Did you
Yeah.
figure that out?
I'm gonna look and see if it might be.
I saw it places, but I didn't really see that it had a definition of what it was.
Yeah.
Take one by one. My car. My car. A back dog. A back dog. A back dog.
And I think that is just the. I wrote it down some once upon a time.
Come on. Come on. My car. Get down my car. My car. Door.
Okay, so that. I'm assuming that X bar is going to be the X with the line above it, and then it says
Yeah.
this, and that is distribution of all the sample means. So the bell curve or the graph
Uh-huh.
is saying that.
Mango.
So,
The sample mean, I think, is going to be that X.
okay.
Mango.
Because it's talking about you like take distribute of X bar to normal and
Okay,
everything.
of all those, that's the sample mean of it.
Yeah. So X, and it makes sense because doesn't that line mean like continue? And I guess since it's all possible sample means.
Okay, yes, yeah. Yeah, there are many possible sample means.
Go to the door. Go to the door. Come with mine. Good top.
All the possible sample means that could have
Big
them.
one top.
Okay.
Big one top.
Don't get on top of your phone.
Big one top, Mom. Big one top. Go in. Oh, get in. No. I get in.
Hmm.
And then with the central limit theorem, that one was if the sample is large, right?
If it's normally distributed
In front.
Oh, okay.
In front, Mom. In
in
front.
the
In front. In
And
front.
the other one is if it's large and oh yeah, law of large numbers. That's right.
Whoa. Whoa. Let's close it one.
Okay.
No.
Oof. So many big words.
Hey,
Come on.
I have.
hi.
You're
So
fast.
sorry.
Come
Gosh. Yeah, I spit a little bit. What are you guys on?
Oh, we were just going over the part 2
Oh, okay.
operation. Do you have any questions or anything about that?
I don't think so. No, I don't think so. I think I got most of it. It wasn't very long this time, which was kind of nice.
Yeah, it was pretty solid.
Reading and everything was pretty good.
Okay.
We cut that.
Okay. You guys want to start the quiz or group meeting?
Yeah. Cool.
Yeah.
Hopefully it's like the homework.
Yeah.
Okay.
Whenever
here we
it's
go.
all done.
Yeah.
Oh, we're great. Lesson 6, right?
Uh-huh.
Hey, guys. Hey,
Alright.
guys. Hey, guys.
Are we ready? Are we on number 3?
Yeah.
Okay.
Okay.
Hey, guys. Hey, guys.
Alright. When taking samples of n, when n equals 5, what was the shape of the distribution of means, histogram, when the parent population is right skewed?
Skewed right.
Is it? Let's see.
Oh no.
Hey, guys. In there.
Let's see. Samples n is 5.
Okay.
My mom. Jimmy, Mom.
Bye.
It would
Have fun.
be right skewed, wouldn't it? Because that's how
That's what I
the
would think.
Because
Let's see,
what?
found it.
when the graph itself, like, are you on that applet thing?
Yeah.
Okay, so the first one, when you put it as skewed, it's right skewed.
Okay. Oh, maybe I should start it over.
And then when you do the sample, it's still looked more right skewed because it's like this. It's moved over this way. If that makes sense.
Okay. Yeah.
For lack of explanation, I do see his hand motions.
No, I think that works. Yeah, I think it'd be right skewed then.
Whoa, that's cool. Oops.
Okay. So, number 4, when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? So, it says,
What is this shape?
for most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that the x bar will be approximately normally distributed. No, that's not a definitive number.
It said the sample size 45 was large.
Sample size of
How do I plug it into this applet thing?
I got our.
I think I
have to get all wet.
maybe I just need to start it over or something. I think I don't know.
I don't know how to do 100. N equals 100.
Yeah.
It just says 5 and then 10,000.
Yeah.
Or whatever it said. No, it said 5. But is this talking about the large? Is it called the large law of large? The law of large.
Yeah.
Because it was even talking about parent population in there. It said like n equals 45 or 35 or something.
Yeah. And it said that was large.
So then, would it be normal?
So sample mean will So
It says, for tremendously skewed distributions, a much larger sample will be required before the distribution of sample means is approximately normal. And it says, for sample size of at least 30, we'll conclude that the sampling distribution will be approximately normal.
Okay.
So, normal?
I think so. Yeah. Oh.
So if it's almost normal, then a sample size of n equals 5 will probably be sufficient to ensure that it will be approximately normally distributed. So normal for the next one too?
Yeah, because it's already normally distributed.
Okay, good.
Okay.
Okay, when would the distribution of means be normally distributed? Data are drawn from a population that's normally distributed and the sample size is small because it's already normally distributed, right?
Mm-hmm.
And then the second one also because it's normally distributed.
Yeah.
Not the third one.
So all of them but the third?
Yeah, all of them but the third. Because it's right skewed, but the sample's large, so it'll make it a normal distribution.
Okay.
Good job.
Okay.
Skewed n equals 5.
So which of the following gives the best explanation of the central limit theorem?
Parent population's normally distributed, then the sample size, then the sample mean will follow a normal distribution. Isn't that what that? Hang on, let's go back to the reading, because I'm pretty sure.
Oh yeah, the sampling distribution of the sample mean will be approximately normal. Okay, if sample size is large, this important result is called the central limit theorem.
Oops.
Let's see.
I think so.
The first one?
Yeah, and also because of process of elimination, because the law of large numbers has to do with the
Slade, come this way, bud. Come
Yeah.
right over here.
The other one is the 68, 95, 98, 74, and that's not what that is. So I'm pretty sure it's.
Okay, that makes
I think you're right.
Slade, come this way, bud.
I think so.
Slade, come here. Come over this way, please.
Okay. Number
Right.
8.
Come
Yes.
on, dude.
Let x be a random variable with population mean equals 10. Population standard deviation equals 6. Suppose a sample size n equals 36 is drawn from this population. What is the mean of the distribution of sample means? Okay. Let's see. Mean of sample mean is the same number as the first one. So E equals the population mean, which is 10, right?
Yeah,
Okay.
I think so.
And then the number 9 is what is the standard deviation of the distribution of sample means?
Mm-hmm.
Okay, and that one, hang on. Should we wait? I just pulled up. Did she disappear?
What? Oh, I didn't even see her. That's funny.
Yeah, because my computer screen, it doesn't do like the little box, like pop-out box. It just completely clears it, so I can't see.
Oh,
Okay.
that's
But
strange.
So 10 is, because it equals it if it's a normal, the x be a random, oh, never mind. It doesn't matter because I remember in the reading it says it's always true no matter what.
Okay.
I remember that.
Okay.
And then 9 is pretty easy. Has no calculator.
Yeah. What? Let's see. What do you put into that? It's the.
It's going to be the equation, the original standard deviation. So
Okay, so 6.
divided by
Okay.
the square root of n, and n equals 36 in this case.
Okay.
Wait, 6 times 6, 36. It's going to equal.
So it's 1?
Thanks.
What did you say?
Yeah, that would make sense.
Sorry.
It's all good.
Man.
I'm very out of shape. Slade, stay here. Okay.
Alright, which one did you leave on, Mel?
8.
Okay. We said the mean of distribution of the sample means. In the reading, it says it's always true. The mean of the sample mean equals the population mean.
Yes.
Which is that backwards Y looking thing.
Okay.
So we said that equaled 10. that sound right to you?
Yeah?
Okay. And then,
Oh, yeah. That makes sense.
okay. And then for number 9, the standard deviation of distribution, we just plugged in that equation of the population standard deviation divided by the square root of n,
Hey,
which we got to equal 1.
nothing.
So do we have to put 1.000?
I don't know. That's weird.
Put like 3 decimal places. And
Mom, please flash. Mom,
Go get it then.
huh?
Go get one.
ooh,
That's weird.
yeah, should we? I don't know, 1.000.
Yes. I don't
Did
know.
we say it was 1.000?
Well, even if it is just the 1, then we can just email him and tell him. We were trying to follow directions.
Yeah.
Yeah.
Okay, so I just put 1.000.
Okay. Sounds
Alright.
good to me.
Awesome.
Number 10. Regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape of the distribution of the sample mean?
Be normal.
Yeah, it'd be normal.
Normal, because it's large, right?
Yeah, and the law of large numbers means that. So it was greater than n equals 30. And everything.
Awesome.
Okay, and then.
Oh, yeah. Well, large numbers.
Wow. Perfect.
Alrighty.
Awesome.
Okay, please be right.
Are we good?
Yeah. Aw,
What?
Man.
it was number 7.
Oh, man.
Dang it.
It's a
And the
sample size.
last one.
Yeah.
Dang it. Aw.
That's so
What?
weird. I was so sure in here it said law.
Not large numbers.
Yeah.
What? Dang it.
Darn.
Oh, look, it's saying the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. And then central limit theorem is talking about.
The shape?
It's over 30.
Okay,
Dang it.
sorry about that, guys.
Sorry, guys.
I thought it was it too. Gosh.
Ugh, that's so like.
One of these days we're gonna get 100.
Yeah, one of these days we will.
Oh.
Each one is worth so much. It's so annoying.
Yeah.
Yeah.
Yeah. Gosh. Oh well, not bad.
Okay. Well, we passed again. Good.
That's right. Good work, team.